Hello guys, welcome back to my YouTube channel. So today we will be solving two questions from the topic geometry, and these two questions came in CAT 2008. So without wasting any more time, let's start the first question. Consider a square ABCD with midpoints E, F, G, H on AB, BC, CD and DA respectively. Let L denote the line passing through F and H. Okay. Consider points P and Q on L and inside ABCD such that the angles, my bad, such that the angles APD and BQC both are equal to 120 degree. What is the ratio of the area of ABQCDP to the remaining area inside ABCD? Okay guys, so as I have already mentioned in my previous videos that it is always helpful to draw a diagram in geometry. So let me first draw a square. Okay. So I have a square ABCD, right? So let me denote the vertices in this order. A, B, C, and D. So E is a point, midpoint, right? And it is on AB. So this is E. Then I have F, right? Yeah, F is on BC. E, F, G. And then H. So then there is a line L which is passing through F and H. Okay. Okay, this is L. Consider points P and Q on L and inside ABCD such that the angles APD. Okay, let's say P is here. This is point P. This is point Q. Okay, this is point Q. So angles APD, right? So I'll join the points AP and PD. Similarly, I will join the points BQ and points Q and C. All right, and we are told that this entire angle is 120 degree, this entire angle is 120 degree. What is the ratio of the area of ABQCDP, okay, to the remaining area inside ABCD? All right guys, so what is the remaining area? Remaining area is simple, right guys? Remaining area is area of, I will write area of triangle APD, right? APD plus area of triangle BQC, right? This is these two triangles. Basically I have to find the remaining area inside ABCD. So these are the remaining area, and I have to find the area of ABQCDP, right? Now if you look at ABQCDP, it is a combination of two trapeziums, right? I can write this is basically area of ABQP. I can write this plus I can write it as area of PQCD, correct? Right guys? Now what is the area of APD? APD APD is basically, let's say, since these are the midpoints, right? E, F, G, H are the midpoints. That means this side is equal to this side, and this is a square. That means all the sides are equal, right? In a square, all sides are equal. That means these are equal points. And let's say this is X units, so this will also be X units, right? Total I'm taking as 2X units. and area of triangle APD can be written as half into base. Base is 2x, right? What is the base? Base is AD, right? AD is the base and this is the height. Why is this the height? This is right angle, right? This is 90 degree, right? This is 90 degree. Definitely this is 90 degree because I am joining the midpoints, right? In a triangle, each angle, not triangle, in a square, each angle is a 90 degree, right? Each angle is 90 degree, and then I am joining the midpoints of the side. That means what? This line L is parallel. Line L is parallel to the sides. Line L is parallel to the sides. That means this these angles will be 90 degree, right? So that means this is the height. So similarly, if this is x, this is also x, and this will be the height. This will also be h, right? This will also be h. So what will be the height? Height will be h. And since these two triangles are similar triangles, in fact these two triangles are congruent triangles, so I will multiply by 2, right? Okay, let's see how I can find the area of ABQP. So ABQP, so this will be x, this will be x. So the entire distance from F to H will be 2x. So this length will be 2x minus 2h. And what is the area of a trapezium? Trapezium area is half into the height. So the height will be this distance. Height will be this distance, the perpendicular distance, right? The perpendicular distance. This is the height. So half into height. So this will be x only, right? Into sum of parallel sides. What is the sum of parallel side? 2x plus 2x minus 2h. So it will be 4x minus 2h, right? And similarly, the area of PQCD will also be the same. So I'll multiply by 2, right? Half into sum of parallel sides into the height. And from the denominator, I can cancel 2 and 2. So I will have 2xh. This 2 and this 2 I can cancel. This x I can cancel. So I will have 2x minus h by h, or I can write this as 2x by h minus 1. So I need the ratio of x by h. Guys, we are told that the entire angle is 120 degree, right? Now see, this is x, this is also x. This is 90 degree, right? I have already told you why this is 90 degree. And this is the common side. HP is the common side. That means this triangle and this triangle is, these two triangles are congruent. Why? Side angle side, right? Side angle side. Side angle side property. Okay, two sides are equal to the corresponding two sides of the other triangle, and the included angle between the two sides of one triangle is equal to the included angle between the two sides of the other triangle. So by side angle side congruency rule, these two triangles are congruent. If these two triangles are congruent, that means this angle will be equal to this angle. That means this is 60 degree, this is 60 degree. Now use trigonometry. What is tan 60 degree, guys? Tan 60 degree. What is tan theta? Tan theta is the perpendicular divided by ratio of perpendicular to the base. So perpendicular is x, right? Perpendicular is there and base is h. From here, x by h will come out to be root 3. Tan 60 is, you need to know this, tan 60 degree is root 3. So I will have 2 times of root 3 minus 1, or basically 2 root 3 minus 1 is the required ratio. A very simple question, guys, not a difficult one, a very easy question. Okay, let's move on to the next question. So we have a right circular cone of base radius 4 centimeter and height is 10 centimeter. A cylinder is to be placed inside the cone with one of the flat surfaces resting on the base of the cone. Okay, find the largest possible total surface area in square centimeter of the cylinder. All right, guys. First of all, again, let me draw the cone. Okay, cone is basically, if you look it as a 2D figure, it looks like a triangle. Okay, now this is the base of the cone. Let me denote the vertex of the triangle as ABC. Okay, guys. Now I will convert this into a cone. Alright, and this is the back side of the cone, which is not visible to us, so I have used dotted lines. Alright, now guys, let's say this is the center of the base of the cone. Now I can put a cone cylinder, right, circular cylinder like this, okay, whose bottom face or the bottom surface, which is this surface, is in line which is resting on the base of the cone, right? We are told inside, it is placed inside the cone with one of the flat surfaces resting on the base of the cone. So this is completely fine. I can also have like this, right? I can also put this as like this. I can also put the cylinder like this, right? There are n number of ways, right? But I need to maximize the largest, like largest possible total surface area. I have to maximize the total surface area, right? I have to maximize the total surface area. So guys, here you need to understand, I will first of all I will erase the cylinders that I have drawn till now. Okay, I will erase this. Okay, this is the center. So you need to understand, in order to maximize the total surface area, the cylinder must touch the lateral surface, the top part, or the basically you have a circular area, right? You have a circular shape. The top face is basically of circular shape, right? So that circular shape, the circumference of the circular shape must touch the lateral sides of the cone inside. Okay, in this way, and the center of the base of the cylinder must coincide with the center of the base of the circular cone. Okay, this is the center again. This is the center. Okay, some can also draw the figure like this, like this. You are minimizing the radius, but you are maximizing the area, right? Like this. This is also completely fine, guys. This is also completely fine, because we have to find the condition for which this will be maximum. Okay guys, here. Okay, so now I will erase the dotted cylinder. Okay, so I hope you have understood till now the concept, like why the center of the base of the cylinder, okay, must coincide with the center of the base of the cone. Okay, now let me join these points. Okay, this is okay, this is here, this one, and this is C. Can you observe a right angle triangle, guys? Let's say the center here is P. Okay, A, P, C, right? And let's say this is Q, and A, Q, let's say this is X. A, Q, X. In these two triangles, if I draw the triangles, I will have something like this, right? A, Q, X, P, C. This is 90, this is 90. This is the common angle. Now guys, we are given that the height of the cylinder is 10. So this entire thing is the height of the cylinder, which is 10, and this is the radius of the, not cylinder, this is the cone, radius height of the cone, and this is the radius of the base of the cone, which is 4 centimeter, right? let's say this is this this is h. So what is the height of the cylinder? Height of the cylinder will be this, which is capital H minus small h, and this is the radius, right? From q to x is the radius, so this will be, let's say, small r. Using similarity, okay, I can say small x by capital small h by capital H is equal to small r by capital R, right? What is small h? I don't know. This is 10. This is r. R is, I also don't know. Capital R is 4. So the ratio of h by r is how much, guys? It is 10 by 4. So 5 by 2. Now, guys, what is the total surface area? Total surface area of the cylinder is basically the surface areas or the areas of the bases, right? Areas of the bases. Why I am writing bases? I have a bottom base here and I have a top base plus area of the curved surface. Curved surface. What is area of bases? Pi r square, because circular bases. There are two bases, so 2 pi r square plus area of the curved surface. Area of the curved surface is given by 2 pi r circumference of the base multiplied by the height of the cylinder. What is the height of the cylinder? Capital H minus small h, correct? From here, let me say that h is equal to 5x centimeter, r is equal to 2x centimeter. I can write this. So 2 pi r square. What is r square? 4x square. So it will become 8 pi x square plus capital H is 10. So 2 into 10 is 20. 20 into r is 40. 40 pi x, right? R is substituting the values of r and h. So minus h is r into h will give me 10x square, 20 pi x square. From here I can say 40 pi x minus 12 pi x square, or I can take 4 pi common. I will have 10x minus 3x square, right, guys? Now I need to maximize this, right? The total surface area needs to be maximized. In order to maximize this, I have to maximize this entire thing. I have to maximize this. I have to maximize this term. Now here we will use a bit of algebra. Okay, this is a quadratic equation. The general form of a quadratic equation, okay, quadratic equation or expression, also you can say, both are different, okay, guys, is basically ax square. I will not say equation, okay. I will write this as expression. Quadratic expression is ax square plus bx plus c, where a, b, c belongs to all the three variables. A, b, c, not variables, coefficients. A, b, c, they belong to real number, and a is not equal to 0. This is okay. So this is also a quadratic expression. In order to maximize a quadratic equation, okay, you learn this in quadratic, okay, in quadratic equations, linear equation and quadratic equation, okay. I will just tell you the result here. The result is that this expression will be maximum, okay, maximum uh, for this entire thing to be maximum, a has to be less than 0, first condition, and second is, at what value of x will this will become maximum? At x equal to minus of b by 2a, okay. For maximum, A must be less than 0. What is A? A is the coefficient of x square. See, here the coefficient of x square is minus 3, guys. Minus 3. Okay, this is minus 3. This is 10x. I can write this as minus 3 x square plus bx plus c. So what is A? A is minus 3. What is B? B is 10. So at x equal to minus b by 2a. What is minus b? Minus 10 by 2 times of 8. A is this one, right? So this will become 5, right? So this will become 5 by 3. This will become 5 by 3. That means this expression will be maximum when the value of x is 5 by 3. So put 5 by 3, guys. 4 pi 10x. So I will have 50 by 3 minus 3x square. X square will be 25 by 9. I have a 3, right, multiplied by 3. So I will have 25 by 3. So 50 by 3 minus 25 by 3 will give me 25 by 3, and I have to multiply by 4 pi. So 100 pi by 3 centimeter square. This is the maximum possible total surface area. Okay, guys, not an easy question, guys. This is not an easy question. Okay, it's a difficult, it's a moderate to difficult level question. Okay, so please, I would say pause the video, look at the solution once again, try to understand the logic behind it. Okay, and this question can also be solved using the, they are like, this is out of scope. Okay, this is a topic that guys who had engineering, or who had in 11 and 12, those who had mathematics, they can solve this question by differentiation. Okay, I have a expression, right? So if I differentiate this with respect to x, I will get 10 minus 6x equal to 0, right? So from here I will have x equal to 10 by 6 or 5 by 3. That means at x equal to 5 by 3, I will get the maximum value. Okay, guys. Okay, obviously maximum. If you can double differentiate it, and you will get minus 6, right? If I differentiate this, I will get minus 6, and this is less than 0. That means at x equal to 5 by 3, it will be maximum. Okay, guys. But if I have to teach this from a CAT perspective, this is out of scope from CAT syllabus. But if you know this, very good, you can save your time. Okay, guys. But if you do not know this, okay, you can use this, that the maximum of a quadratic expression will occur when the coefficient of x square is less than 0, and at what value? At x equal to minus b by 2a. Okay, this I will teach in my later videos. In later videos, I will be teaching the concepts of all the topics. Okay, now I'm just solving the some of the important PYQs and uploading them, putting the solutions and concepts involved. But later I will deep dive into the each topic. So don't worry, guys, if you have not understood this. But please remember, like, how to find the maximum or the minimum. Okay, in this case I have not mentioned the minimum condition. Okay, as we are not asked, but just remember this, the general expression, and when the maximum will occur. All right, guys, I hope you have understood both the two questions, and I hope you are able to solve it. And if not, don't worry, guys, just practice more and more questions, try to understand the concepts and the logics involved, and don't memorize any formula, guys. Don't memorize any formula. In that way, you will, you will definitely do well in the quantitative aptitude, guys. So thank you, and I will see you in the next video.